Okay, we are live. Hello, everyone, and welcome to the final live session of the Dragon Agents Bootcamp by AI Planet. So, we're delighted to have you join us today for an exceptionally insightful and informative session. I am Shreehari Pandey, and I will be moderating today's event. So, for today's session, we are thrilled to have two distinguished speakers with us. First, we have Chanukya Patnaik, the founder and CEO of AI Planet. With his visionary leadership and deep knowledge of AI, Chanukya will provide invaluable insights into building agentic workflows. Joining him is Shreehari Vaasistha, a senior software developer at AI Planet. Shreehari's technical prowess and practical experience will ensure a thorough and effective demonstration of Open AGI. So, in this session, Chanukya and Shreehari will explore building agentic workflows with Open AGI. They will provide an introduction to an overview of various agentic frameworks and will also have hands-on project demonstrations. So this session will be an excellent opportunity to learn from seasoned professionals. So without further ado, I think we can start.
Hi, yeah,
Yeah.
yeah. Just give me one moment. Is my screen visible? Yeah,
Yes. Yeah.
great. Hi everyone. I hope you're doing well, and thanks for joining into the session. I'm Chanukya. I'm the founder of AI Planet, and with that, let me probably quickly walk you through what we are going to um, take away in this session. So first off, we are going to understand the intuition behind agents, what autonomous agents are all about, and what are its current limitations, and what is the current state of LLM systems, and what it is going to be future. And that's where we're also going to talk about how these agents going to evolve, and how humans are going to evolve along with these agents, right? Apart from that, Shrihari and Shivaya will walk us through some code demos on OpenAGI, and then that's where we'll also be emphasizing on human intervention. We'll also briefly talk about the theory on versus sequential planners and do some demo use cases of the code. So with that, first of all, let me get started with agents, right? Um, and if you have any questions in between, feel free to ask. I'll be happy to take them during the session or post the session. In the first place, when we talk about agents, unlike any other forms of AI, agents actually try to mimic human beings, right? So we are literally creating human beings. And when I say that, like human beings have perception, right? When I say human beings have perception, like we all can see around what's around us. We can also hear. We can smell. Like humans have a perception. Similarly, agents have a perception where they can take input from the environment. And how do they take input from the environment? They can take input from the environment via images, video, audio, or documents, or anything of that sort, right? So similar to humans, how we are taking information from the environment. And like humans have a brain where we might end up having some sort of a short-term, long-term memory, and that brain also helps us to reflect on the feedback that is given to us from other fellow human beings. And also we have the ability to make decisions, right, with the intelligence that we have from the brain. Similar to that, agents also have the capability of a brain where they can make decisions, they can plan, they can reason, they have access to their long-term, short-term memory. And I'll talk about the intuition behind it on how it works in real world. And that's all about the perception and brain. And when it comes to actions, right? So like I as an individual, I as a human, I can take actions with the help of my hands, limbs, and other things. Similarly, agents have the capability to take action by using certain other tools. Let's say, like if I'm talking about as a human, if I'm talking about searching for the weather report tomorrow, right? There are two ways I can do it. One, I either need to have a weather machine at home, where I could probably forecast it. That's where I still need to switch it on and probably figure out, right. And the other way is probably I use my intelligence where I can plan and where I can try to search on Google and find for some weather applications, and through that I can find what is the weather in my location. And similarly, when it comes to agents, they have access to certain tools like we have access to tools. Agents can also be provided access to tools so that they can allow us to make some action. The action could be as simple as finding the weather report for tomorrow, or writing a piece of code and running it on top of the code editor, or it could be anything, right? So this is how like humans, agents have a perception, brain, action, ability to take action, and that's how if when I look at it that way, when we talk about autonomous agents, we are literally mimicking and building humans, and like humans who self-improve over a period of time, agents are also expected to self-improve, and they become autonomous over a period of time, right? So that's a bit of understanding on what agents are. And if I have to put this in practice, when I talk about let's say how we are going to see agents evolve over a period of time is that, let's imagine you as a software developer, you're doing your first piece of project where you joined as a junior developer in one of the organizations, and you are asked to build a payment gateway app, and this is your first project, right? And in the first project, what happens is you're asked to deliver an objective. I mean, you're asked to deliver a particular solution called as payment gateway app, and the first thing that you would do is you would plan to accomplish this task, right? And after doing the planning, you would break it down into 3-4 subtasks, and you will start executing each task at a time. And then eventually what you would do is eventually you would end up producing your application, the solution, and then you would give it to your manager, whoever has is supposed to review. And once the manager reviews, you might have to take it to iteration 2, iteration 3, based on the feedback you get, and eventually you will take it to the production, right? So this is the very first time where you are building a particular application for a company, right? And now the same application, now imagine after 10 years later, you have become a very seasoned developer, where you have done more than 100 projects across different organizations, right? And now again, you got a new task where you are asked to build a payment gateway integration for a different industry altogether. Now in this case, what inherently you do as a developer is that you would end up utilizing your long-term memory that you had back in your first project to see how maturely, or how in a better sense, you can build this payment gateway integration, right, during your 100th project. So similarly, we use our long-term memory. Agents have the capability, I mean, provided we provide them the capability to use its memory, they have the capability to use their long-term memory to make decisions, to plan, to execute. And not just that, if they have done some mistakes in the past, they will also try to learn from those mistakes. And how do they learn? Whenever they execute something, humans might end up producing a piece of code, and your manager, or let's say you end up getting some errors. That's a feedback that you're getting, right? That means this doesn't work. So you utilize this learning experience in future. Whenever you're writing a piece of code, probably you wouldn't execute, you wouldn't write it that way for the similar problem statement. So similarly, agents would learn from its past experience, past memory, and try to rectify them whenever they're seeing a new objective or a new task that is given to it. And with that, I'll probably talk about the current state versus what we are going to see in the future, right? So when I say current state, what are the current LLM systems that are available out there? So right now, if we look at it, be it with the retrieval augmented generation applications, or even any of the LLMs that we are seeing out there, most of them are aggregating information and synthesizing that information on top of the existing data, right? So and most of it has a cutoff limit in terms of the knowledge base. They are trained on a particular set of data, and they still have some limitation on that. That's where things like techniques like retrieval augmented generation is providing it with external knowledge base. That is to some extent it is. It is ruling out, it is basically taking away that cutoff challenge, but still, like, there are other limitations, like for example, the current state of LLMs are still not very good at reasoning, decision making, or even for that matter, they fail at complex coding tasks or mathematics puzzles or anything of that sort, right? I'll also probably walk you through one of the examples that way. Whereas in future, what we are going to see is, like, these agents, are be it agents or different form of AI, it's going to plan for you, it's going to reason and make a decision and also take an action on behalf. When I say this, I'll probably give an analogy of a software developer here again. So let's imagine you asked something like ChatGPT or any other LLM to write a piece of code for a particular problem statement, right? In the first place, what it would do is probably it'll help you to produce a piece of code, right? Like I'll probably do your live demo on this. Let me just probably flash my screen. I also prepared a problem statement. So for example, I just took this particular problem statement, and I'll probably open ChatGPT for you. Okay, so here I already ran this, but, like, let me just run it for you again. Solve the following problem. Right. So this is a simple math problem, and let's see what an LLM does. Right. So it'll probably end up trying to solve for me, and it might end up giving me some solution. Right. And it doesn't know, it doesn't validate whether this solution is actually correct or not. Okay. So it is left to me whether, like, it is correct or not, right? And in some cases, if it is being used by a student who is 10 years old, might as well, they might think this is correct, and they might end up learning something incorrect, right? So the same thing, like, when it, like, right now, like, we don't know, like, what it is actually about. So the same thing if I use an agent in this particular scenario, right? So probably, like, here I just ran an agent, like, which is a math agent, and what it is predominantly doing is, whenever I give a piece of question to it, first thing what it is doing is, it is doing a simple planner like this. It does a simple Google search about the math problem or the related topics, and then take the top 5 most relevant information about these topics or about this problem, and generate a step-by-step solution. Okay. And in case if it doesn't find relevant information, or in case if it doesn't find any information about this problem statement, it'll probably tell me that, okay, I don't have information about this problem. Whereas in the case of the traditional LLMs that we see, it would end up generating a particular piece of answer, right? So right now, if you look at this, it has given us a lengthy step-by-step solution, and it says that the answer to this particular question is 5, which in reality is not true. Actually, the answer to this particular question is probably 8. Okay. Again, I'll probably quickly do a Google search here just for the reference, right? So here, if I look at it, like, this is the particular problem statement, which is given on a particular website called as Stopper properly. So here, using digits, so and so 1, 2, 3, 4, so and so sequence of digits, the number of 5-digit numbers that can be performed, so that each number is a palindrome, right? So this is the question, and the solution to it is option A, that is 17. Okay. And whereas when we look at our question, the question is that it is asking for the sum of digits of P. That is, here P is equals to 17, and sum of digits is 1 plus 7, right? So that's where, if you look at this particular agent, it has actually given a correct solution in comparison to the existing LLMs. So the reason why I gave this example is right now, there are limitations with LLMs where they can end up hallucinating them. If you ask any question, it has an answer, right? And it doesn't validate whether it is correct or not. Similarly, if you ask it to write a piece of code, it'll end up producing a piece of code, and it doesn't validate whether it is correct or not. And that is the current state of LLM systems. Whereas what we would see in future is where when it comes to the agentic workflows or other things, if you ask it to write a piece of code, it will not just generate that piece of code, but it will also make a decision for you to run that piece of code on an IDE and see whether it is producing errors or not. And it will also write test cases to see whether it is accomplishing the given task or not. And in the process, let's say it is getting some errors, right? Like humans tend to debug for errors. It will also look at the errors. It will try to debug the code. It will try to make another decision for you to fix that code, and eventually produce a code that could be much more accurate enough, right? Which you can use it in the production. So that's where it'll plan for you, it'll reason for you, it'll make a decision for you, and it'll ensure the entire validation is taken care of, provided you provided with the right tools in the process. So that's where we are going to see much more better accurate results with something like agents. And again, I'm not saying these have evolved. Right now it is still in the evolution phase, and we were still in the nascent stages where we haven't seen a lot of agents being into production. And the most important thing is, like humans, they also self-learn over a period of time, right? So that's the most important thing. Whenever they are getting a feedback, they try to take that feedback and try not to repeat that mistake over a period of time using their memory as well. So I hope that's clear on what we are right now versus what it would be in the future state. And this is a good example of the math agent that I was just referring to. It is a very simple math agent. Again, it's not validating here. It does a very, it's probably one of the basic use cases that I just wanted to show to give you an intuition that way. And yeah, with that, let me probably take you through the next thing. So when it comes to agents, right, I think we already spoke about some of the essential components. I'm sure some of the speakers in the past would also have walked you through this sort of a slide. So some of the essential components are planning, and then what all entails in planning. Agents should be able to reflect. When I say reflect, like humans reflect on the feedback that is given by, let's say, a manager, their manager. Let's say I'm an employee working in an organization, and I might end up getting some feedback from my peers as well as from my manager or anyone, right? So that's where I need to reflect on that feedback. So similarly, in the planning component, agents should have the ability to reflect. They should have the ability to self-critique. So before I deliver any piece of task, or before I deliver my task to anyone, be it to my manager or peer, I will ensure to self-critique myself, right? So that is the capability that agents need to have. And there should be something like chain of thoughts, where I need to have a better reasoning about each and everything. And similarly, sub-goal decomposition. When I say sub-goal decomposition, it's nothing but something like a plan, right? So when I showed you this particular math agent, I was doing some step-by-step process. Like step one would be to search for this particular problem on the internet. Step two would be extract all the context from the top websites. Step three would be use the context to solve the problem and give the step-by-step solution. So this is my plan. Okay, this is the plan. And after that, I execute each of these small pieces of plan. And that's when action and tools come into picture, right? And when it comes to tools, it could be you provided access to, we have access to so many applications, right? Humans have access to so many applications. If I have to run a piece of code or do search or want to search about a particular topic on internet, I can just go to Google, or I can access my IDE locally and run a piece of code, right? Similarly, agent should be provided that authentication or ability to use certain tools. So that's where that's more important. So and memory part, I already spoke about it. So that's one of the very essential component. Like planner, memory is also super important. where it needs to have short-term and long-term memory. Short-term memory to try to make it more cohesive for a particular task. Whenever they are doing, they need to have short-term memory on what is happening before in the preliminary step or a step before, and they need to have that overall context. Otherwise, it would end up hallucinating after step 5, step 6, or so on and so forth. And that's one of the major issues right now. Most of the frameworks or even most of the production use cases are failing, where after you go to step 6, 7, 8, agents tend to hallucinate because they may not have a good short-term memory, right? And similarly, like the long-term memory should also be there, but it is able to use some of its long previous mistakes or previous learnings that it had and use it to leverage in performing the existing tasks, right? So this is about the essential components of agents. And now, when I talk about it, like what the future is going to be, right? Again, I mean, before I jump into this, maybe Shiva, if there are any questions, I'll be happy to answer. Or also, like, I just wanted to check practically if the voice, everything is audible or not.
Yeah, you're perfectly audible. We have two questions.
Okay. Okay, got it. So I'll just move on with this. So when we talk about the future, right? So that's where, like, right now, like whenever we talk about humans, right? Like and then when I talk about a particular company, a company might, let's say, if I'm talking about a software company, the company might have a bunch of product designers, a bunch of product managers, a set of software developers, marketing, sales. So it could comprise of different people, different functions, different people from different backgrounds and other things, right? So similarly, as we evolve, and like as we see agents evolve over a period of time, we would end up seeing a village of agents which are trying to optimize and which are going to help us in accomplishing some of our objectives, right? So that's where it is going to automate certain things that humans can potentially do as of today, be it writing a piece of code or even executing that piece of code and so on and so forth. And that's where we would end up seeing a village of agents, not just for companies, but also as personal agent assistants for humans as well, right? So this is going to happen in probably, like, I wouldn't give a specific timeline, but as we see things are evolving, like we would end up seeing agentic workflows being more common and common. And when I look at it right now, as a software team, or like as a technical team, if someone is asked to build a particular product, or if as a software developer, if someone is asked to build a particular product or a solution, they have to go back and start from planning, right? They have to plan it, and then after that, they have to after planning, they have to have their architecture ready. They have to decompose the task. They have to decompose and then allocate each of these tasks to individual software developers, aggregate all the tasks that are being developed by these developers, and then eventually take it to the testing phase, user acceptance phase, and then eventually release it, right? So there is that entire software development life cycle that a senior engineer or a lead engineer has to take through, right, along with the product managers and all. Whereas probably in future it could be slightly different, where instead of developer going through this entire process, they might end up asking agents to, when I talk about a developer, I'm talking about a single developer. And instead of the developer going through the process of planning, executing the tasks, and then optimizing the code and then taking it to the production, instead, like they could use an agent as an assistant to actually produce a piece of code, to allow it to plan and review that plan, and then allow it to execute the task. And then instead of they doing the entire work of writing the code from scratch, they would now just optimize the code that is already written by the agents, right? And then take it to the production. This could be the phase one, and the phase two could be something else, right? So this is how we might end up seeing where the nature of humans, the nature of the roles of humans might change over a period of time. Right now, we may have to do everything, but in future, we may end up doing certain things, the most critical tasks, and we might end up automating certain other things. That will also leave us with more time to focus on certain other things as well, right? The most pressing problems out there within an organization, or even there are many more problems that agents or the generative AI cannot solve, that the humanity is facing. So there are enough problems in the world, like, which can be solved by humans, and that might also walk us through the consolidation phase that way. And this is a simple graphic I wanted to show, where it is something that is built by ChatDev. It's an open source library you might want to go through. Where, as you can see, I mean, like, they have um, a tribe of agents, like, where they primarily help in software development tasks. So as you can see, there is a designing team that is sitting out here. There is a coding team. There is a testing team. There is a documentation team. So there are different bunch of agents which are executing different tasks, and we might end up seeing this kind of a virtual dev studios going forward as well. This is something that is in making that way. But if you haven't checked out, I would strongly recommend you to check out ChatDev and a few other open source tools as well. And all being said, while these are super fancy, still, like, when it comes to agents, there are limitations, and there are some limitations in terms of what they are capable of, what they are not capable of, right? And when we talk about agents, like, it's not just the software, it's not just the digital agents that we are talking about, where, like, which can work on with APIs and all. We can also integrate it into a hardware, right? The agents can not just be integrated in software, but they can also be integrated in hardware, and that's where the robots, humanoid robots, come into picture, right? As simple as something like a robo cleaner also uses some components that I just spoke about, be it perception, planning, and taking an action, right? So now, all these being said, right now, like, I'll probably quickly walk you through what are the limitations that we have with regards to agents, right? Right now, the biggest limitation that we see is the brain, that is the LLMs itself, that the large language models. While they are great, they are language models, and they are able to process natural language pretty well. But unfortunately, they were never trained, or they don't have bias. And when it comes to agents, they always tend to take an action, right? They have to execute something, or they have to plan something. They're always bound to take an action, unlike LLMs, which just processes natural language. So that's where, like, there is a huge delta in terms of you know LLMs not being great at planning, or even reasoning, or even solving some of the complex coding and math problems. And in short, they don't have bias for action. And right now, when it comes to planning, it's more like a forced prompt, and that's where you would have learned about React Agent, LATs, and a few other prompts, which were developed by several researchers with a lot of experimentation. That is something you might have already learned in the previous sessions. And also, like, we'll also be sharing that material with you. And out of all, and there is some level of inconsistencies or hallucinations that are not just brought in by LLMs, but also by agents, right? You never know, like, what I'm not saying, like, agents are always correct, right? So, like, humans make mistakes, agents can absolutely make mistakes, and they might, but the good thing is they might end up learning over a period of time with the kind of feedback it gets from the environment, right? So that's where, right now, when we speak about it, like, right now, it's important for a hybrid intelligence approach, where we strongly believe in human AI collaboration, where you still use AI, but also use human intelligence in order to make meaningful decisions, right? So that's where, when it comes to agentic workflows, or even RAG workflows, right now, when we talk about some of the big enterprises, there are certain areas where they are fully automating. There are areas where they are using this kind of a hybrid approach, and there's also the need of the hour, because we cannot let things be in a autopilot mode, fully automated, because The risks are also very high, and these are in its very nascent stages that way. And with that, I'll probably quickly jump to introduction to OpenAGI, right? Again, when I talk about OpenAGI, it's an open source library for helping you build your own custom agents. And as I just spoke about different components, OpenAGI has different components as well that are needed to build your own agents. Like it has components like memory, a short-term, long-term memory. It has a component of planner. It has a component of LLM where you can try to leverage the capabilities of LLMs. And not just that, it has something like admin and workers. Admin is like a manager, and workers are like the managers. Sorry, workers are the employees reporting to a manager, right? So when you're delivering a particular task, if it is a really big task, the admin will allocate some of the subtasks to individual workers. So that's where this admin worker thing comes into picture. And also admin also controls and consolidates everything. It also gives feedback to individual workers, and it also tries to communicate what needs to be done. Not just communicate, but also gives some set of memory events that are needed for individual workers to accomplish the task, right? So when I say that, as a manager, if I'm giving a particular task to my let's say mentee or someone, then obviously I need to give them some context. So similarly, whenever an admin is getting work done from a worker, it has to give adequate context. Otherwise, the worker will have no context about it, right? So that's where there are different components that are there, which would allow you to build these autonomous agents. And that's where I'm sure Shiva and Shreehari will give you a code walkthrough on that. But before that, I'll probably walk you through two simple use cases. One is more on the architectural level, right? One is a simple blog writing use case, and the other one is custom learning paths. So probably let me just quickly walk you through on that. Yeah. So when I say custom learning path, right? So I'll probably let me just give you some context on what a custom learning path is. Whenever you are asked to learn a particular topic, right? So you might end up going to a particular learning platform like Coursera or Udemy or anything of that sort, right? And your way of learning style could be different from my way of learning, and each individual's learning style could be very different from others, right? And that's where, in an ideal scenario, probably you might want to have a particular learning path that works for you. And it could be possible that your favorite sports person is Roger Federer, and you like to only consume content in the form of video tutorials, not in the form of text. Then ideally, when someone is generating a learning path for you, they should not just create most of the learning content in the form of interactive videos, but also induce some examples of Roger Federer so that it makes it exciting for you, right? So that's how you might end up engaging with the content more, and you might end up engaging yourself and also understanding the topics as well a bit better, right? So that's more on the interest level. But when it comes to custom learning path, it could also be possible when I talk about it technically, right? When I'm learning something like data science, or let's say learning about agents itself, I'll probably talk about the classic machine learning side of things, right? So machine learning, you can teach with intuition, or you can also go into the depth of the mathematics side. So I might be someone who might be very excited about math and really doing good with math. And if I'm taught with the complicated math stuff, I might understand it. But if the same thing is done to other person who is not at all good with math, and just be afraid if they end up seeing some complex mathematical equations, then it might backfire for them, right? Instead of they picking machine learning, what they would do is they would end up stopping to learn, which is a very big red flag in my opinion. Instead, they need to be taught in a particular way that allows them to get started into a particular topic that fascinates them, rather than making them afraid of the complexities that are involved in learning a particular topic, right? So that's where, so what this particular agent does is it creates custom learning paths based on the interest of the student, and not just that, based on the performances that they get over a period of time, right? In each and every lesson and assessments, what it does is it will automatically take them into consideration, and it'll dynamically generate what the next lesson should be. So that's where, I'll probably walk you through this architecture on how a particular agent could be built. For example, if I have to build a custom learning path, right? The first and foremost thing is I need to have a knowledge base of all the courses content, which is a generic knowledge. Let's say I'm having all the details about mathematics, science, and physics, which I got from some XYZ learning platform, right? This is a super generic content where it has the textual content, it has videos, it has exercises, and so on and so forth. And now the first and foremost thing this agent one does is, whenever a learner comes onto the learning platform, it tries to understand what do they need to learn. Let's say if they want to get started with introduction to Python programming, or if they want to get started with introduction to machine learning, it tries to take that goal, and also it tries to take the interests of the student. And using these two details, it'll start generating a learning plan, and then probably the first assessment as well, right? Before even it generates a particular lesson, it'll probably start creating an assessment. And after a prerequisite assessment is given, another agent will come into picture, and it tries to critically evaluate the assessment and tries to understand what are the weak points identifier. And using those weak points, now that information is taken by agent 3 to generate a new learning path for the student. And it not just generates a new learning path, but it will also try to understand and reinforce some of the content patterns, right? Let's say, if the student has to be repeated, like for example, when I talk about teaching something like A for apple, B for B for ball, C for cat. So if we have to be taught vocabulary or any other topic, right? We were not taught one day and we were left to learn. We had to be, as kids, we had to be reinforced with that learning over a period of time, where we were taught that in multiple sequence of intervals by giving a gap, so that these topics or this vocabulary is reinforced in our memory, and eventually we start imbibing them into our ecosystem, right? So similarly, this critic agent, what it does is it takes care of having some algorithms like spaced repetition, which will try to ensure in what intervals do I need to repeat certain topics to these students, so that there is proper reinforcement. And then eventually, this is fed to the agent 1 again, which takes care of creating a new lesson each time. So what happens is, here is how it goes, right? The first and foremost thing is, whenever a student comes, the student already has certain interest and certain objective in mind to come to a platform. And given this, they are given a prerequisite test. Based on the prerequisite test, a particular learning path is created for them. Let's say lesson 1, lesson 2, lesson 3, and so on and so forth. And after that, they are delivered these lessons, right? After delivering the lesson 1, they have assessment 1. And after this assessment, based on the results of the assessment, and also based on the interactivity with the lesson, like how much time they are spending, whether they are engaging the videos or the textual content or not. So using these interactivity metrics and also the assessment metrics, another agent will analyze it completely and try to create a lesson 2, which is dynamically generated, which was not planned earlier, right? So this is nothing but a dynamic planning, where you don't know what would be your lesson 2. Of course, I mean, you have to accomplish this objective to learn something like introduction to Python programming, but what will come next is something that will be planned by the agent, keeping into focus how has been your performance in the topic, right? So that's where I'll probably show you a simple data point on how this goes. So for example, in this particular case, the objective is to learn introduction to Python programming. And initially, this is the learning path that was generated by the agent. The first and foremost is it wanted to teach the student with introduction to Python, and it wanted to do a small activity of a video tutorial, and then like it wanted to give a quiz. Lesson 2 is about data types and variables, some content, activity, and interactivity, and lesson 3 is control structures, and then there is a final assessment, right, which is more related to coding task and also quiz. Okay. And once this entire path is done, what second agent does is it tries to critique by analyzing the performance of the student. That's where the assessment scores are taken based on different topics, and not just that interactivity metrics like time spent on each lesson and engagement levels and other things. And then what it does is it tries to identify what is the weak points identification, right? So using this data, now what it does is instead of giving the second learning path, which is like, which is very common for everyone, what it does is, given this student is struggling with certain things, let's not go to the next topic. Let's try to reinforce some of the other topics which they are already struggling with. That's when it dynamically generates lesson 4, lesson 5, and so on and so forth, right? Which is very different from what it was originally planned. And this way, what it does is like, it'll allow you to personalize and create that adaptive learning experience. And you don't need to go with a generic approach where everyone is taught in a particular fashion, right? Lesson 1, lesson 2, lesson 3, lesson 4, and so on and so forth. Instead, each and every individual's needs could be different. Each and every individual's learning style could be different. So that's where something like a custom learning path generator could actually do the magic for students who are struggling in that direction. But yeah, I mean, like, that's where I'll probably take a pause and give a brief intro on blog writer agent as well, which Shivaya is going to do a quick code walkthrough. So I think, like, when it comes to the blog writer agent, what this agent would predominantly do is it'll help you to write a blog on a particular topic, right? So first and foremost is like, when it comes to agent, like, the first and foremost thing is the planning, where it needs to, like, in this particular case, whenever an agent is given this particular task, the first and foremost thing is, as a human, like, let's think about like a human, right? First thing is you would research about the topic and you will try to collect all the, second is you'll try to collect all the relevant information about the topic, and then try to write a compelling draft, right? And the third thing is you would try to review and edit the content for factual accuracies, and then deliver that particular blog to the manager, or like to whoever you have to report to. So similarly, like, this is the planning, and then you go through the task execution phase, and that's where I'll probably leave the floor to Shivaya to do the code walkthrough so she can go through this. Thanks. Yeah.
Okay, so should we go with the questions, or should we go towards the end?
Sorry.
The questions. We have a few questions. Okay.
Have questions? Okay, I mean, we can pick some questions if there are. I mean, I'm happy to. So,
Okay. We'll add them to the screen.
for example, if I need to do the weather research search, agent can do it for me and give me the data. But would it be capable enough to improve the prediction percentage using historical data? That's a good question. Thanks for the question. Yeah, I mean, like, probably in that case, what you potentially need to do is you need to have another agent which is capable of doing machine learning or deep learning modeling, right? So it can potentially do, and it should not just have the capability to do that deep learning models, to build that deep learning models, but also it needs to be provided that access. Yes, I mean, to answer your question, it is feasible, but for that to happen, you need to give it with some custom tools as well as data. Yeah. But if you ask me, it is pretty much probable. Second question, are people building agents on production? Isn't it pretty costly running this? And also, what about latency? Are people building? Actually, the wave for agents came with AutoGPT and few other things, right? Almost like 1.5 year ago. Again, I'm learning Phil with from other researchers from the Bay Area, and thanks to them. So I think when we look at the evolution, right, though there was a lot of buzz about agents almost from 1.5 year back, till now we haven't, I mean, till late January or something, even at that time, I was still seeing people experimenting. But lately, in the last few months, I have seen some production level use cases for sure, which are operating at scale. And that being said, are they not costly? I mean, they're super costly, and they have to be run in a uh, rather like batch processing is the best ideal right now, right? Because they take a lot of time, and also it needs a lot of human input. So still, we are in the very nascent stages at the moment in terms of productionizing these agents. Yeah. I have a question. Why should I go for these in particular rags while have Gemini? It can also do things in real time. Okay, so I think models like Gemini, ChatGPT, they have a cutoff limit. That being said, let's say you as an enterprise, right? Let's say or you as an individual have 1,000 documents which are not listed anywhere publicly, and these are written by you. These are only stored in your local computer or on Google Drive, which is not even accessible on internet. And let's say you created your own programming language, or a new what do you call new human language. Imagine, let's take that imaginary thing. In that case, if you ask Gemini about your new coding language called as C hash hash, okay, Gemini would have no context, and that's where you need to give context to Gemini through retrieval augmented generation. I mean, I think that's where RAGs are super helpful, where Gemini may not have all the information that is available on the planet, especially the private information, and not just that. Even when it comes to certain things, they might end up hallucinating, right? The problem with these large language models is, given any question, they're ready to answer it for you, and they don't know whether it is correct or not. They don't do the validation. So that's where, in order to reduce the inaccuracies, reduce inconsistencies, and other things, I think it's important right now. Still, RAG has the future. So yeah, I hope that addresses your question. How could we serve these agents to end users? How should they be hosted? Yeah, I mean, agents. I just showed you one quick demo, right, on a math agent where it could be given in the form of a chatbot, and also the GPTs that we are seeing on OpenAI are also sort of agents. So you can give it in the form of a simple chatbot, or even in the form of uh, a simple API as well. And yeah, and how could we serve these eight? I mean, I think these are the forms you can serve. And when it comes to hosting, I think they are similar to how we host any other RAG apps or anything, right? I mean, where you have all these components, you try to um, I think that's where I'll probably let Shreehari address that, because he has deployed some of the agents, and probably I think he's a better person to talk about it. But in general, it is no different from hosting any other large language models or large language model applications like RAGs. Okay. So we'll talk about it. And, yeah. Or yeah,
Yeah, yeah, that's
yeah.
it for now. I think we can start with the
Okay.
code
Okay.
walkthrough.
I think we can take the remaining questions a little later also. Yeah. Okay.
Yeah, sure.
Yeah. Maybe yeah.
Okay, I hope my screen is visible, that I'm audible. Okay. Hi. So I'll be walking you through a code example that demonstrates the use of AI agents with specific workers. So this code leverages Open AGI framework, which allows us to create autonomous agents. Okay. So first, we have to install the Open AGI package using the pip install function. So this library provides necessary tools and modules, everything that you would need to build an AI agent. So after installing this package, it is important that you restart the session or going to the runtime and sorry, you can like restart the session from here. So this way you won't have any dependency errors when you use open source modules, and all dependencies are correctly loaded and ready for use. So next you will import necessary modules like the write file action, which allows our agent to read data of file, and the DuckDuckGo news search, which helps us searching for news through DuckDuckGo. So we also have web-based context tool, which loads web pages, and then we have admin, memory, task planner, and the worker, which are all parts of the OpenAGI framework, and will be discussed later. And we have OpenAI model for the large language model. So for this example, we are using an OpenAI large language model. So you would need your API key. So you can get that from the website, and you can enter your okay. So you can enter it here in the environment. So we are using OpenAI here, but you can use OpenAI supports various other models like Azure, Rope, Gemini, and Hugging Face models. So each model has its own strengths. So you can experiment with whatever works with your project. Next, we configure the large language model here. So this is a crucial step. The configuration is loaded from the environment. So it will make it easy to switch between different supported LLMs if you're using multiple ones. And next we come towards the workers, which are the team members here. So we're creating workers in this project, which is basically a blog writer project. We have three workers here: a researcher, a writer, and a reviewer. So this is how you write the code for a worker. You give it a name, you give it a role, instructions, and actions. So these actions are nothing but the tools which the worker would use to perform the actions. So here we have three workers. So the first one is responsible for uncovering the latest developments in AI. The second one is a writer, which will take the information from the research analyst and then uh, uh, craft compelling content based on the research findings. So this worker transforms the complex concepts into engaging narratives. And third, we have a reviewer worker, which ensures that the final blog post is polished and aligns with everything you wanted to. So you give it a role, and then you give it a prompt. Like this one has a prompt to uncover developments, and you give it a prompt on which it has to work, and then you give it and then to the actions part we give it the tools which it needs to work. Like here we have the DuckDuckGo news search tool and the web-based context tool. So you can create custom tools here to suit your specific needs. This flexibility allows you to extend the agent's capabilities beyond the built-in tools. So in this code I'm just using the built-in tools. So, okay, next you define the admin agent. So the admin is the master task executor responsible for overseeing the entire process. It uses a task planner here, which breaks down the entire task into many subtasks and assigns it to the workers to streamline the process. So here this human intervention is turned false, which means that the task will be executed without any human intervention from the user. It will be fully automated, and the memory included allows the agent to remember the previous interaction, improving its ability to handle context and provide more accurate results. So this is how we assign our admin. We give it the planner, the memory, and the LLM. LLM here is the OpenAI LLM we had defined above. And next we run the agent. So when we finally done it, we give it a specific query. Like here, the query is to write a blog post about the future of AI. So this involves conducting research, writing the content, and then reviewing and editing it for clarity and everything. So once you run this and you print the response, the admin would run, the task planner would divide the task between the task planner, between the workers, and at the end you would get the result. So this is okay. 1 minute. Okay. So this is basically a run through of how the coding part of OpenAGI works. So it highlights the capabilities in creating autonomous agents covering most of the components. So I encourage you to explore the GitHub examples and documentation for more detailed information and more advanced use cases. Next, we have Shreehari who will be presenting his project, which would also include human intervention set to true. So you would get an additional layer of interaction in that. So I think we can start with that now. Hi, Shreehari. You can you're on mute right now. You're on mute right now. Yeah. Hi, can you zoom in a little so it's more clear? Yeah. Actually, you're not audible. Can you check your mic? Hello?
Hello. Yeah. Am I
Yeah.
audible now?
Yeah, it's audible now. Great.
Okay. Sorry for the delay and some technical glitches. Yeah. So just to start with the walkthrough of how you can build your own agent using OpenAGI framework. I'll just give a quick walkthrough similarly, but I'll try to go a bit deeper as well to help you guys understand how you can customize as well in between. For your use cases. And there were some amazing questions like how we can optimize the cost. So I hope I'll be able to answer those questions as well. So yeah, to get started, I'll be setting OpenAI API key. So we are using OpenAI model itself for this use case as well, and we'll be setting the API key as an environment variable, and then we are configuring the model that we support out of the box from from OpenAGI. So and then we have something called multi-agent architecture, where admin we configure our admin agent, and we'll assign it a team of workers for it to coordinate and achieve the given objective. So first we'll configure our admin with the task planner with human intervene equal to true. So as we know, most of the time in real world, whenever we need to achieve an objective, we first try to plan it and then kind of decompose it into smallest subtask, into an achievable subtask, and then we kind of start approaching from either we'll take either a top to bottom approach or bottom to up approach. So in the similar way, we have human intervene. So what it does is, while the objective is given, it tries to go forward and tries to interact with the human and gets better clarification or more clarification from the user for the given objective if it's not entirely clear. For example, let's say we have given it an objective of, hey, give me a 3 days itinerary to a 3 days trip to San Francisco. But there we have just mentioned 3 days trip, but it can ask more questions like whether we want to attend it in more we where we need to attend some of the tech events or non-tech events, or we need to prefer some restaurants like vegetarian, vegan or non-vegan kind of. So those kind of approaches we can definitely take. That's where the human intervention will help. So what we had to do is we had to import this task planner class from OpenAGI.planner.task decomposer and enable human intervene equal to true. So then we configure memory. So what it does is admin, while it is, so here we are using something called short-term memory. So how it is helping is, since we'll have multiple workers, which I'll just show in a minute. Uh, it tries to maintain those events that has took place in those each worker's execution in events, and tries to use it in further subsequent agents as well when required. And then we are passing the LLM. Our LLM is nothing but OpenAI here, which is like the brain of this admin agent. Then then we are defining workers. Here we have mainly three workers. First, it is customer feedback collector. Here, the use case that we have picked uh, is to create a simple report, a feedback report on for AirPods Pro. Basically, we want this will help in users who are trying to buy, let's say, AirPods Pro, and or be it any other products, right? We have to just replace here as with the placeholder, and we should be able to and the agent will be able to achieve the given objective and give us relevant results. So in the same way, we have three workers. So the way this helps us is, instead of having one agent to do all the tasks, and each age since agents are under the hood, it even has LLMs which access the brain, and brain has some kind of context limitations that it can hold. So we have tried to create multiple work sub agents. So workers are nothing but sub agents that admin will coordinate with, and it need not have entire context to store in its brain, and rather offload it same way that we do it in real world. Let's say, as Chanukya gave an example of software development team, whenever there's a project, the manager or the tech lead kind of delegates, first does the planning and delegates each of the subtasks to his teammates. So that's how, in the similar way, we have configured customer feedback generator. So sorry, collector. So first it goes to various, it tries to get some feedback from various sources, online sources. And we have added the capabilities for this worker. Actions are nothing but it can be tools, or it can be capabilities that you offer to the worker in a particular fashion. Um, that's where we had given a DuckDuckGo search, web-based contextual, and write file action. So file action is something you guys might have been thinking, why is it required here? So one of the reasons is, let's say while each worker is doing its task, it usually as in real world we try to create notes while we are working to make sure that we don't miss it out in the future, and it can even help us as a kind of a memory in the long term. In the same way we are kind of writing it, it can be helpful for us as a humans for debugging, or as a developers for debugging, or even for admin to read it, or for other workers, subsequent workers to read it. So in the same way, we have data analyst worker. So this worker is responsible for criticizing. The same way we just, as Chanukya mentioned, a critic that will kind of goes through with the report that is collected and tries to analyze that data and kind of get it in consensus with the objective as well. So that's where it will analyze the data, and we are also providing it the instructions that in what way it has to in what way the worker has to act. In the same way, it has to identify the key trends, like highlight the recurring issues of mentioned by different various customers from those online sources, in the same, and also like determine overall sentiments towards the AirPods Pro. And at the end, we also want to generate a report, as the objective says. That's where we have report creator. All it does is it kind of gets all this data from different workers and tries to analyze it. And I mean, analyzation is done by the data analyst, and the rest and the task of this report creator is just to generate a report in the expected way. So that's where we have instructed this worker to develop the report, which should include like it would highlight the key findings from the data analysis worker, and also identify the trends and recurring issues as well. And also in the same way, we have given it some capabilities similar to other workers as well. And then we are assigning these workers to the admin, saying, "Hey, this is your team. You are I mean, you are free to go ahead and achieve the given objective." So that's where we have admin.run. So query is nothing but the actual query of the customer, and description is nothing but how, basically, description of the admin role that it has to perform with respect to the use case. Let's say you are building a tour agent. That's where you can have a description of uh, like description that is more relevant to a tour agent, and you can have the query here as create a tour or itinerary planner and leave a placeholder here for to get the input from the users whenever you are giving some kind of UI to the to for the users to access. The similar way that is built for math agent, where we provided the question and there was a placeholder that was mentioned here, and it tried to analyze different sources and make sure it got a best answer that it could, that it was relevant, and it where we kind of tried to uh, reduce the amount of hallucinations as well. And then it will admin.run will return the results back. That's where we have assigned the result to rs, and we are just printing it. So now let me go ahead and run the agent, which will take couple of seconds or minutes to run, and we should be able to seeing the results as well. Um, is the terminal visible? Let me know if it's not.
Have you shared your screen yet?
Yep. I'm sharing it. Yeah.
The terminal isn't visible right now.
Mm,
Okay.
yep. Is it up?
Yeah, can you like zoom in a little
Okay.
if that's
So yeah,
possible?
I just ran this, and actually it kind of finished the task as well. So let me just give you a quick walkthrough of what happened when I ran the particular Python script that I had. So this is the one. This is the file that I have created the agent in, and I'm just running it. So in the first place, what it did is it tried to ask me some kind of questions where it asked me if I want to get the feedback from relevant online sources, which is helpful because I don't want it to go and search in every available resource online, which might not be relevant. And I feel like these are the ones relevant or kind of reliable for me. That's where I asked it to go and search only in these three things. And then what happened under the hood is it tried to understand my requirements, along with it asked me some clarifying questions like the specific online resources I needed, and it tried to create a task, decompose the task into multiple steps, and then it started running each task one after the another by assigning each task to a worker which is relevant. So all these things happened by the admin itself. So admin took the responsibility of running, decomposing the task and assigning it as well. So at the end, it after everything happened, it took around 3 minutes, and it was able to give me the output as well and the report as well, which included the customer report with the key findings that I required, like what were the key findings. Uh, that is, it had, the AirPods Pro has an enhanced noise cancellation, feature appreciation from different customer, like particularly on transparency mode, spatial audio, and stuff, and also the comfort that it gives compared to the other versions, and also the recurring issues that customers have kept on specifying, like battery life, which and also the durability issues. Overall, I also wanted to know the overall sentiment of the customer in general. That's where it gave me that it's generally positive. So there was also a question log, how we can optimize, right? So that's where when we want to understand the sentiment, we don't necessarily need an LLM to generate this particular sentiment. We can just use a simple sentiment analysis model and assign it to a particular worker, which is responsible for just to analyze the sentiment and then return it. That's how we can, save the cost and at production level as well. Definitely, there might be other uh, ways as well, but this is one of the way I would suggest to go ahead. And also planning is the crucial stage, and in the same way we can have different LLMs for admin, different LLMs for each of the workers that we have. That is the kind of flexibility that OpenAGI provides, and you're free to customize it as per your use cases and improve it. So under the hood also, in the execution engine, it's not just about where it just gets the subtask and it directly goes and achieves it. In between, there will be issues. Let's say one of the links are broken that we got from the web search. So it will try to understand that it is broken, and it will try to go forward, and it won't just stop there. That's where we have to, that's where we have this custom mechanism in each of the workers, and basically the OpenAGI framework to understand each of the steps that in the subtask, then subsequently take the next steps as well. So yeah, this is how it works. Any questions? Feel free to ask them.
Okay, I think we can take the questions now. It is shared on the screen.
Sure. Let me check. Getting attributed error when importing web-based context tool. Um, do you mind? I think this is a bit. I mean, I'll have to look at what exactly is the error. That's when I'll be able to answer this particular question. So, if I can get the exact traceback or something, that would be definitely helpful. Or you guys can even reach out to us over GitHub, file a GitHub issue, and definitely we'll get back.
GitHub or Discord.
Yeah, Discord. Yeah, definitely. Thanks.
Okay, we have a second question.
Yeah, that's a
I
great
think
question.
Shreehari. Yeah.
Yeah. So how description and query is different. So query is basically kind of specifies what is the actual question, whereas description kind of, we are providing we are defining how our admin agent should work. Basically, we are defining the exact role that it has to perform. Instead of, it's like, if it's a tech lead, it has to behave as a tech lead, rather than behaving as, let's say, a designer or something else. So that's how, admin. That's how the query and description is different. Yeah. Does OpenAGI shows output step by step, like, let's say? Yes, yeah, we do log each and every step that's happening, and there are you can definitely go ahead and customize it and also run it in a debug mode to get more of the logs and more verbose approach. Um, yeah, but but just to summarize, yes, it does log each and every steps that it takes under the hood, not just the admin. It also about also the workers that the steps are being taken by from. So the agent framework that provide the costing information such as token use. I think there are various frameworks that I have noticed, particularly QA, which definitely shows the tokens used from each worker, and also I think that is one of the features that is coming to OpenAGI. So stay tuned for that.
And also probably like there are, just to add to Shreehari, I think there are other tools land use and also something else whereas
Yeah.
which provide you observability, right? Where you can not just track how many tokens are being used, but also you can calculate the cost. You can also see what kind of responses were given at what stage and what are the latency. So you can get much more sophisticated information about the entire observability aspects if you look into the specific observability frameworks like Langford and all, which can also be technically some sort of a tooling mechanism for these agentic filters. Or you can post it separately as well and just keep it. Um, and in talking about this, LangChain has its own way of setting up agencies, and we respect LangChain AI. I think these are some of the amazing frameworks, right? Again, everyone is evolving. No one knows, like, this is the defined part. If you look at some of the inventions that we have seen, be it with internet, electricity, or any other things. I think before they were invented, they have gone through a transitional phase for about 10 years where everyone is figuring out what is the best way to do it. Things that used to be in the form of libraries probably 6, 7 months ago now became obsolete and being part of, let's say, like a model itself, right? So we are in that transitional phase where everyone is figuring out what is the best path. Even now, if you look at, we spoke extensively about agents and the future of agents, but there is no defined way to crack it. And I think there is a need for more players to actually come, disrupt, innovate, and explore what is the potential and how the entire world can actually harness this kind of sophisticated advanced technologies, right? Be it in the form of agents or maybe in future agents could lead us to artificial general intelligence as well, right? So I think I personally believe, or like in general, I personally believe that like there are limited things that are available out there which are taking you to production. And right now we are talking about so many things, but still like there are very little agents that are in production, and that's an unfortunate thing. So we still didn't get to that stage of democratization, and we need more players and even people who are watching out there. We need more enthusiastic entrepreneurs or builders who can come and chip in and probably make it much more viable and useful for the entire global community, right? So that's where I'll probably pause. Maybe Shreehari, if you want to add something more on the technical aspects, you can also add. But yeah. But again, I mean, that being said, I think each of these frameworks have its own functionality. Autogen provides some other functionalities. Screw AI does something. OpenAGI something. But I think eventually all of them allow you to build agents. Some of them might have limited functionalities, but I think there is some sophistication which we will be happy to share at a later stage. I didn't want to cross compare that way. So yeah. Maybe share you want to pick this. I think it's a follow up question.
Yeah. So yeah, under the hood, we do some kind of additional changes to that. But even that is kind of customizable for a developer when they are using the framework. Uh, just one word answer, yes, it is possible.
Yes, I mean, I think you can definitely build that. There's no doubt about it. Again, so there are tools like Olama, which allows you to run these LLMs. I mean, like run some of the open source LLMs on your local machine. So you can potentially use some of those LLMs to run these RAG or agentic workflows. Otherwise, you can also access some other free APIs, right, that are given by Grok or Replicate or a few other players. Definitely, I think you can definitely use that. That being said, I think you can also use some proprietary models like OpenAI or Azure Chat OpenAI, whatever it is. They do provide some free credits, so I don't think it should limit a student to develop RAG or agentic workflows. I think there is enough players who are providing you free resources out there, either in the form of APIs or you can self-host your own models on your local machine. Especially someone like Olama or Llama CP, I mean, that has actually brought LLMs to be processed on the local computers, right? So those are some of the breakthroughs we have already seen. So would strongly encourage. Don't worry about the cost. I think there are enough tools that are available that would allow you to build these. So
Yeah, I think that's it with the questions.
yeah.
I do have one more. Okay.
I think they can fix that. It's just that I think there are more. So every problem needs to be solved by an agent, right? Not every problem needs to be solved by something like generative AI. I think there might be, in my opinion, something like captions could be solved by a much more sophisticated, specialized model, which takes much lesser compute, much lesser resources and all. That being said, yes, I mean, agents are like humans. Right? That's how I treat it. Like we're just literally clone a human brain to each and every amount that we have. So humans can write captions, so can agents do that to answer your question. If you're developing a Q&A tool for some document in any format, to what see, I mean, this is very subjective, right? Again, I mean, like there are agentic RAGs and other things. RAG is also, I mean, like you can also use RAG systems within teams. Okay, that could be just a simple document. So you can use both in collaboration. There is no defined way of speaking about like how to. Again, when I talk about a document can have different types of information and like you could different types of content. So when I say I'm going to have a section, it could have a table, it could have an image, it could have some enumeration points. So you have to take into consideration all these things. I think the first and foremost important thing is whatever we spoke about, one thing that we can touch base on is your data pipelines. Okay. If your data pipelines are not really great, no matter how good LLM you end up sending garbage into the LLM and maybe sending you the garbage out, right? So here specifically, like when I talk about if you have a table, if you are not sending the table the way it has to be sent, then it is going to go for a toss, right? So when I say that, I ideally wish to show an example. I'm not sure whether the probably like I will throw that example um, post this session to all of you. But definitely, I would want to throw one example that helps you to understand how a particular what it is. Okay, I just got an example. Just probably flip my screen. So, so when I specifically talk about documents has different types of information. For example, here I'm just showing you particular type of information, right? So here I'm passing this information very categorically in the form of a markup. Okay. The reason why I passed it in the form of a markdown, not a simple copy paste, is if I do a copy paste, LLM wouldn't understand that this is the heading and and this is the like, horizontal or vertical segment. These are the individual values that are corresponding to devices, and this is the individual value that is corresponding to the behavior and so on and so forth. That's where I categorically fed the data to LLM in the form of a markup, because that's when it will understand that okay, this particular data is mapped to this year, this particular data is mapped to this level. So if your data extraction and process, or if your data pipeline is not really good, what happens is you end up feeding LLMs with garbage data through your retrieval algorithm, right? And once you retrieve and augment junk data, when it comes to generation using an LLM, it will also provide not source true. So in short, your retrieval and data pipeline has to be really good. And I think in developing a Q&A tool, I think that would provide you with fairly easy results. I think you could also use a agentic bag also to actually do the I hope
Okay,
that answers
so yeah, I have added the GitHub and the Discord everything in in the comments. So in case someone wants to reach out. Okay, do you guys have any closing thoughts before the session ends?
I mean, you're asking me, or
Yeah.
no? Thanks. I mean, thanks for the session. I think it was amazing to see a bunch of questions. I know I'm like, we are coming to the closure of the boot camp. I wish everyone the very best. I hope it allowed you to get started with the RAG pipelines, as well as it allowed you to get introduced to the world of agents. And I'm sure it will go a long way. Just be curious. Just understand the intuition part of it. Rest of the things, I think once you understand the intuition, you'll be excited about it, and that will allow you to do the more clinical task of learning how to build an agent, or how to understand the math behind all large language models and other things. So again, all being said, there is so much evolution that has to happen even in agents. Especially, I was talking about the limitations of large language models and all that. So that's where there is a need for large action models. So we are just talking about these pipelines, workflows, but someone actually need to work on the core algorithm, or like the modeling part as well. More people who can put creative thoughts on how to build these large action models that can not just cater to one industry but also several industries. I think we need more researchers, more students, professionals going forward with those thoughts and collaboratively contribute to the open source community in terms of not just partnership but also in terms of building some of the school models or workforce overall. And I wish you the very best, and I hope we can answer this sessions. Yeah, thank you.
Okay, so I think we can end the session now. Thank you so much, Chanukya and Shreehari, for that insightful and comprehensive session. Thank you for our audience. This is the last live session from this bootcamp. So if you guys have been sticking around since the beginning, thank you very much for being here. And thank you very much for your time and effort that you put into the presentation. Yeah, thank you very much.
Thank you. Bye. Cheers.